Chapter 1. The night belonged to them. In the winter of 1942, German bomber crews had every reason to feel confident. The night was their domain. British cities lay vulnerable below them, and the RAF's attempts to stop them seemed almost laughable. Out of every 100 bombers that took off from French airfields, maybe 3 or 4 would fail to return. Those were acceptable losses. The British could barely touch them. The German engineers were even more confident. They'd seen intelligence reports about British radar systems, those massive towers standing along the coast, the so-called chain home network. Primitive, they said. Crude technology operating on meter-long wavelengths, useful only for early warning, nothing more. The idea that the British could guide fighters onto bombers in the pitch darkness, using radio waves bouncing off metal, absurd. Major Joseph Schmid, the Luftwaffe's chief intelligence officer, had submitted reports dismissing British defensive capabilities. Even when radar was finally acknowledged, it was downplayed. British fighters were tied to their ground stations, Schmid insisted. They couldn't assemble quickly or coordinate effectively. The technology simply wasn't there. The Germans had their own radar, of course. The Freya early warning system had been operational since 1940, and they'd developed the Würzburg fire control radar for their anti-aircraft guns. But airborne interception, that was different. That required miniaturized equipment, sophisticated displays, split-second coordination between pilot and operator. The Germans were working on it, certainly. Their Liechtenstein system had achieved its first kill in October 1940, but they assumed the British were years behind. They were wrong, catastrophically wrong. Because while German engineers were congratulating themselves on their technical superiority, British scientists had already solved problems the Germans thought were impossible. By early 1941, the Bristol Beaufighter equipped with AI Make-5 radar was operational. The radar operator sat facing backward, watching 2 cathode ray tubes that showed approaching aircraft as glowing blips. One display showed azimuth, the other showed elevation. Together they could guide the pilot onto a target in complete darkness. On the night of November 19, 1940, a Beaufighter from 604 Squadron had scored the first confirmed kill using this system. A Junkers Ju-88 flying through the darkness over England suddenly found itself in someone's crosshairs. 4 20mm cannons tore into it. The crew never knew what hit them. That was just the beginning. By the spring of 1941, the kill rate was climbing. In January, 3 German aircraft shot down by AI-equipped fighters. In February, 4, March 22, April 48. By May 1941, 96 German bombers fell from the night sky, most of them to these radar-equipped night fighters. The Luftwaffe noticed, of course. Losses were increasing, but Hermann Göring attributed it to many things. Bad weather, mechanical failures. Perhaps the British searchlights were improving, but Radar Göring refused to allocate significant resources to Germany's air defense. In November 1943, when production chief Erhard Milch warned about the threat of American fighters arriving in the spring of 1944, Göring dismissed it. The Eastern Front was the priority. Cities could burn, he said. The German people had lived before there were cities. This arrogance would cost them everything. Chapter 2. The Hunters Become the Hunted. By 1943, the tables had completely turned. The RAF wasn't just defending anymore, they were hunting. The introduction of the de Havilland Mosquito, that wooden wonder made of plywood and balsa, transformed night fighting. Fast maneuverable and equipped with increasingly sophisticated radar, the Mosquito became the scourge of German bombers. The AI Menke 8 radar was a revelation. Operating at microwave frequencies on a wavelength of 9.1 centimeters, it could detect targets at low altitudes, where the older meter wave systems were blinded by ground clutter. The parabolic dish antenna spun and nodded, painting a picture of the sky that the earlier systems could never achieve. Range increased to 5.5 miles. Accuracy improved dramatically. But the British weren't content with just shooting down bombers. They wanted to hunt the hunters. German night fighters equipped with their Liechtenstein radar were taking a heavy toll on RAF bombers attacking Germany. So, British scientists developed something brilliant and devious, a system called Serrate. Serrate was beautifully simple. German night fighters used their Liechtenstein radar to find British bombers. That radar transmitted on known frequencies between 485 and 505 megahertz. Serrate simply listened for those transmissions. A specially equipped Mosquito could detect a German night fighter from up to 100 miles away. The German pilot, confident in his technology, would be stalking a British bomber, his Liechtenstein antenna arrays bristling from his nose. He wouldn't know that someone was stalking him. The Mosquito would close in using Serrate to track the Germans' radar emissions. Then, at shorter range, the hunter would activate his own AI I4 radar for the final approach. The German night fighter pilot might notice in his last moments that strange aircraft appearing in the darkness. 4 20-millimeter cannons. The end came quickly. By late 1943, the Luftwaffe's night fighter force was bleeding. They were still effective against bombers claiming hundreds of kills, but now they were vulnerable themselves. The night sky, once their domain, had become uncertain territory. And then came Hamburg. Chapter 3. Operation Gomorrah. On the night of July 24, 1943, 791, RAF heavy bombers lifted off from bases across England. Their target was Hamburg, Germany's second-largest city, a vital port with massive shipyards that had built vessels like the Bismarck. The weather was perfect. The bomber stream formed up and headed east across the North Sea. Inside each Lancaster, Halifax, and Stirling bomber crew members opened brown paper bags. Each bag contained 2,200 strips of aluminum foil attached to coarse black paper, 10.5 inches long, 3/4 of an inch wide. At the designated moment, they began throwing these strips out of their aircraft, 1 bag per minute. The Germans called this stuff Duppel. The British called it window. Today, we call it chaff. On the ground in Germany, radar operators watched in horror as their screens exploded with false returns. One bomber became 10, became 100, became thousands. The carefully coordinated German air defense system, which had been inflicting terrible losses on RAF Bomber Command, simply ceased to function. Ground controllers couldn't direct the flak guns. They couldn't vector night fighters onto targets. The radar screens showed nothing but a blizzard of electronic snow. Hamburg burned. The first raid killed about 1,500 people, but that was just the opening act. On the night of July 27th, the bombers returned. This time, they created hell on earth. The weather had been hot and dry. The city was tinder. The combination of high explosive bombs and incendiaries, concentrated in one area by Pathfinder aircraft using H-2S navigation radar, created a thermal cyclone 2 miles wide. Winds reached 150 miles per hour. Temperatures hit 800 degrees Celsius. People in bomb shelters suffocated as the firestorm sucked the oxygen from underground rooms. Those caught in the open were incinerated instantly. Witnesses described hats being torn from heads and whirled through the air like burning fireballs. Asphalt melted, steel beams bent under their own weight, brick slowly liquefied. Lead and aluminum ran like water through the streets. When the bombing finally ended on August 3rd, over 42,000 people were dead. Another 37,000 were injured. 1 million civilians had fled the city. 300,000 buildings were destroyed or damaged. The RAF had flown 2 the 355 night sorties. The Americans added 235 daytime raids. Nearly 9,000 tons of bombs had fallen on Hamburg. And the loss rate: 12 aircraft out of 791 on that first night. Just 1.5%. Window had worked beyond anyone's wildest dreams. Albert Speer, Nazi Germany's Minister of Armaments, later told interrogators that the Hamburg raid made an extraordinary impression. He'd advised Hitler that if the Allies repeated this success on 4 or 5 other German cities, Germany would collapse. The psychological impact was devastating. Field Marshal Wilhelm Keitel wrote to his wife on August 3rd, expressing his terror that Berlin would be next, describing streams of burning oil, phosphorus, tremendous heat, the danger of being trapped in shelters as fires raged above. Chapter 4. The Baby Blitz. The Germans tried to respond. In January 1944, Hitler ordered Operation Steinbock, nicknamed the Baby Blitz. The Luftwaffe scraped together 524 bombers for a retaliatory campaign against London and other British cities. Goering, always eager for revenge attacks, threw his support behind the operation. Finally, Germany would make Britain pay. It was a disaster. By this point, the RAF had 16 squadrons of Mosquito and Beaufighter night fighters, all equipped with AI radar. Fighter Command had reorganized specifically for night defense. Ground-controlled interception radars worked seamlessly with airborne systems. The coordination that German intelligence officer Schmid had once declared impossible was now routine. The British also had window. They'd been reluctant to use it initially, fearing the Germans would copy it for use over Britain. But after Hamburg, that concern seemed quaint. The Germans had already developed their own version, Dupel, but Goering had ordered the paperwork destroyed, worried about Allied retaliation. From January to May 1944, German bombers struggled against a defense that seemed omniscient. RAF night fighters intercepted them with ruthless efficiency. The Mosquito, with its speed advantage and sophisticated radar, was particularly deadly. Losses mounted rapidly. Of the 524 bombers committed to Steinbock, 329 were shot down. That's a loss rate of over 60%. For comparison, RAF Bomber Command's losses over Germany during the same period averaged around 5.76%. Steinbock accomplished almost nothing. It caused minor damage to British cities, killed some civilians, and provided propaganda value for Goebbels' radio broadcasts. But strategically, it was meaningless. Worse, it destroyed what remained of the Luftwaffe's bomber force, just as the Allies were preparing to invade France. When D-Day came on June 6, 1944, Germany had no significant bomber capability left to oppose it. The night bombing campaign was over. The technology the Germans had dismissed, the radar systems they'd called primitive and impossible, had won. Chapter 5. The Radar Revolution. The transformation was staggering. In 1940, when the Luftwaffe began, the Blitz night fighters were almost useless. Hurricane and Spitfire pilots would take off into the darkness, hoping to spot a bomber silhouetted against searchlights or fires on the ground. It was desperate, inefficient, and rarely successful. By 1944, night fighting had become a precision science. The entire defensive system worked like a well-oiled machine. Chain home stations detected incoming raids from 150 miles away. Ground-controlled interception radars at sites across Britain tracked the bombers' progress and vectored night fighters into position. The fighter's own airborne radar took over for the final approach. IFF systems prevented friendly fire. The pilot barely needed to see the target. The radar operator called out ranges and directions, closing 2,000 yards, 1,500, 1,000. At 400 yards, the pilot could usually make visual contact. The 420-millimeter cannons would open fire. Another bomber would tumble from the sky, and the hunters could be hunted. Serrate-equipped mosquitoes prowled the bomber streams, listening for German night fighter radar emissions. The Luftwaffe's own defensive system became a liability. Every time a German pilot switched on his Liechtenstein radar, he risked attracting a British night fighter. The Americans, initially skeptical of night operations, enthusiastically adopted British technology. Western Electric manufactured the SCR 540, their version of the AIMEK-4, for installation in American night fighters like the P-70. The radiation laboratory at MIT, formed after the Tizard mission, brought British cavity magnetron technology to America, designed over 100 different radar systems during the war. Half of all radars deployed in World War II came from MIT's work. The Germans tried to catch up. They developed the SN2 radar to replace the Liechtenstein, operating on different frequencies to avoid serrate detection. But production lagged, and by the time it entered service in significant numbers, the war was already lost. German technical expertise couldn't overcome the massive Allied advantage in research development and manufacturing capacity. The Germans had also made fundamental miscalculations about microwave radar. Their engineers calculated that at centimetric wavelengths, most of the transmitted energy would scatter in all directions, making it useless for detection. The British solved this problem with the cavity magnetron in 1940, a device that generated sufficient power at microwave frequencies. When American engineers saw it during the Tizard mission in September 1940, they were, in the words of one observer, shaken. The technology was years ahead of anything they possessed. The Germans learned of the cavity magnetron's existence, but convinced themselves it was impractical. In mid-January 1943, German authorities ordered all work on centimetric radar to stop. It was a catastrophic decision. While British mosquitoes prowled the night with their centimetric AIMEK, Thieke radars, able to detect targets at low altitude and track them with unprecedented accuracy, the Germans were still relying on their meter-wave Liechtenstein systems. Chapter 6. The Price of Arrogance. By 1944, the Luftwaffe's night fighter force was still claiming significant numbers of kills against RAF bombers. In the 11 months, from January to November 1944, they claimed 2,235 bomber losses out of 2,434 total RAF losses, an effectiveness rate of over 91%, but their own losses were mounting. In the same period, the night fighter force lost 806 aircraft. The kill ratio had dropped to 3 bombers for every night fighter lost. That might sound acceptable, but it represented a dramatic shift. In 1941, German night fighters had claimed 421 kills while losing far fewer aircraft. By 1943, they were losing 1-8-16 bombers, but suffering increasing casualties themselves. The Mosquito escorts, the Serrate Hunters, the improved defensive armament on British bombers, all took their toll. And German night bombing. It had effectively ceased to exist. After Steinbock ended in May 1944, the Luftwaffe never mounted another significant conventional bombing campaign against Britain. The V-1 flying bombs and V-2 rockets took over the terror campaign, but those were different weapons for a different war. The era of the manned bomber attacking at night was finished. The Americans, meanwhile, had solved the daylight bombing problem. The arrival of the P-51 Mustang in December 1943, with drop tanks extending its range to 850 miles, meant American heavy bombers could reach any target in Germany with fighter escort. The Luftwaffe's day fighter force, already struggling, was systematically destroyed in the spring of 1944. By the time of D-Day, Allied air superiority was absolute. The radar revolution had fundamentally altered aerial warfare. Before, radar bombers had been nearly unstoppable at night. The bomber will always get through. Stanley Baldwin had warned in the 1930s, but that was only true in a world without radar. With radar, the night fighter became the dominant force. The sky was no longer a hiding place. It's darkly ironic that German engineers, so confident in their technical expertise, missed the significance of radar development. They'd pioneered the technology. The Freya system was operational before Britain's chain home, but they failed to push the boundaries, failed to imagine what was possible, failed to take the threat seriously until it was too late. Perhaps it was the institutional arrogance that infected Nazi Germany's leadership. Göring, convinced of Luftwaffe superiority, couldn't accept that British scientists might surpass German engineering. Schmid's intelligence reports dismissing British capabilities reflected what his superiors wanted to hear rather than reality. And when evidence mounted that something new and deadly was killing German bombers, the response was too little, too late. The order in January 1943 to halt all work on centimetric radar was particularly damaging. While British and American scientists were collaborating, sharing breakthroughs, pushing the boundaries of what radar could do, German researchers were told to stop. Politics, rigid thinking, and a fundamental misunderstanding of the technology's potential combined to cripple Germany's efforts. By the time German intelligence obtained a working example of British AI radar in 1943, analyzing it carefully and understanding its sophistication, the gap had become unbridgeable. The Allies were producing radars by the thousands. They were training operators by the hundreds. They were refining tactics, improving systems, building on success. Germany couldn't catch up. The night had belonged to Germany in 1940 and 1941. By 1943, it belonged to no one. And by 1944, it belonged to the Allies. The technology that German engineers had laughed at, that they'd dismissed as impossible or impractical, had won the night war. When Hamburg burned in July 1943, creating a firestorm visible for miles, it wasn't just a city that was destroyed. It was Germany's confidence in night operations. The introduction of Window had rendered their elaborate air defense system blind. The increasingly effective Allied night fighters, guided by radar systems the Germans had thought impossible, turned every mission into a gamble. And when Operation Steinbock failed so catastrophically in early 1944, losing more than half the committed force for negligible results, it marked the end of an era. The Luftwaffe would never again mount a strategic bombing campaign. The bombers that survived Steinbach would be used for tactical support, attacking Allied ground forces performing reconnaissance. The strategic air war was over, and Germany had lost. The irony is complete when you remember that Germany had developed its own version of window Doppel and tested it successfully. But Göring ordered the knowledge suppressed, fearing Allied retaliation. When the British used window over Hamburg, the Germans scrambled to rediscover what they'd already invented. Precious months were wasted. By the time German bombers used chaff in their own operations, it was too late to matter. The radar war was won by scientists, mathematicians, and engineers working in labs and workshops, testing concepts that seemed impossible, pushing the boundaries of what technology could do. It was won by factory workers mass-producing complex equipment. It was won by radar operators sitting in darkened rooms, watching glowing screens, calling out bearings and ranges. It was won by night fighter crews, trusting their technology closing in on invisible targets in the blackness. And it was lost by those who laughed, who dismissed, who thought they knew better. The German engineers who scoffed at British radar capabilities learned too late that confidence without evidence is just arrogance. And in war, arrogance kills.